Hello, hi guys, good morning, welcome back to the new video. Sorry for being late. I woke up pretty late. I tried my best, but I slept 1 hour just at 3. But yeah, in this problem, firstly, if you want to get the intuition, please skip this part of 5-10 minutes. I'll speak. So basically, whenever the problem comes up probability, I was the one who was the most scared out of all. So that's how I will teach you that how to think of the questions when it comes to probability specifically, right? So it's gonna be a very good problem. How to think from scratch, going on, what can help you in thinking itself. It will actually help you. Cool. Now let's quickly jump on the example itself, explanation itself, which says that we are simply having n cross n chessboard. Okay, I will have simply an n. By that n, I can get to know the size of chessboard, which is n cross n. And a knight, we have knight, which means in Hindi we said it as ghoda, or a knight we have, and you know how the knight moves, right? A 2.5 moves. It just goes 2 and then half. 2 and then 1, 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 2 and then 1. So it is how a knight moves in 8 directions. 2 and then 1 moves. Cool. So we know the static size of the knight, which is row and columns, and he attempts to make exactly k moves, which means in one move he reached here. In next move he can again try to go any of the 8 directions, and he will, okay, in one move he reached here, right? In next move he will reach other 8 directions. So basically he can try to move exactly 8 moves. He will try to move exactly 8 moves, starting with this cell, row, comma, column. Cool. And it's just, or everything is 0 indexed, which means the top left cell is actually a 0, 0, and the bottom right is actually a n-1, which means the top left cell is actually a 0, 0, and the bottom right cell will be a n-1, n-1, which is simply a 0 based indexing, which we have 0, 0, n-1, n-1, right? Now how a knight moves in a chess is represented in this blue diagram. No worries at all, but yeah, for your more understanding how actually from some coordinate I, j, you can move to other coordinates. If you are at some coordinate 0, 0, if you want to move to 8 directions, just simply add. That's the reason I just showed from 0, 0 to actually the new coordinate location. So if you have any coordinate I, j, just simply adding this 1, 2 in I you add a 1, in j you add a 2, then you will reach this particular point, which means to move to the 8 directions, simply add these, which means in corresponding x, add your I. It is simply how you move in a grid, in 4 directions, in 8 directions, and simply how a knight moves itself. So that is how I showed you that, okay, how a knight can actually move in from any coordinate I, j. From 0, 0 you saw it moved to 1, 2. If it had been I, j, so it would have moved to I plus 1, j plus 2. And that's how you can simply move to all 8 coordinates, all 8 directions you can simply move on. Now coming back to what we have to do. That's how we saw the problem. Okay, that is what it is given. But at each time the knight moves, what happens? It chooses 1 out of 8 possible moves uniformly at random. That is one word, uniformly at random, which means that 1 out of 8 moves are as equal, which means every move, every one, which means which means every move out of those 8 moves are actually equal. So basically it just says it choose 1 out of 8 possible moves uniformly at random. Every word has a meaning. 1 out of 8 moves. No, it's not right, but yeah, 1 out of 8 moves choosing uniformly at random, which means every move has equal probability to get chosen. Cool. Now it just say, okay, even if the piece is out of the grid, or no worries, what still. So basically what we know from this part is that if a knight moves from one location to the next location, and we know that every location has equal probability of being chosen, right? Every location has equal probability of being chosen. We know, let's say the probability of being chosen of every location is x. It is x, it is x, it is x, and we know it is equal. We know it is equal, right? And also we know that the sum of probability is always equal to 1. So basically it says 8x is equals to 1, or x should be equal to 1 by 8. So basically saying that going on to this particular point, out of, or simply you can easily say that you have 8 points. You can easily say that 1 out of 8 possible locations I have, that simply I can say that 1 by 8 is a probability of movement of a knight. It's not that knight, it is k n I. It is knight. which means the actual piece, right? To move in one of the 8 directions. Now, okay, see, both ways you can find the probability. It is just how we read it, and it is how we mathematically define it, right? Now, cool, no worries that you have got how we can find the probability of movement of knight at one point. Now, the knight continues moving until it has made exactly k moves. So basically make sure that knight will keep on moving until it has made exactly k moves, or it has moved off the chessboard. If it has moved off the chessboard, so for sure it moves will stop right there, right? We have to return the probability. That's the reason we just specifically stressed on probability itself, and it is something we were, while reading the question itself, we were building out. Okay, one out of 8 possible uniformly at random. Okay, that's a 1 by 8 probability. Now, we have to return the probability that the knight remains on the board. So basically, I am concerned of the knight remaining on the board after it has stopped moving, which means after completing exactly k moves, if the knight still remains on the board, that is how I want to know the probability of the knight. Now, coming back, see, now we have understood the problem itself, because the problem, understanding every part is very important, and to grab every information. Now, coming to the example, now we will try to grab the information from the example itself. From problem, we got information whatsoever we needed. Now, we need more information to actually how to solve. For that, example will help us. Fixing the first example, we will start from a row 0, 0, and then we have to do exactly k moves. So remember this part. Now, as we saw that every time the knight moves, its probability gets reduced by 8, because initially it is 1. Initially the knight is inside the grid, it is 1, and moves to 0. As soon as it just moves, it just have another move, its probability will get reduced to 1 by 8, right? So what will happen is, initially start from 0, 0, it is here. Now it has 8 possible options. Outside is shown by this dotted line, right? So that's to know, okay, there is also possibility going outside, but it will for sure not go, because outside it cannot go. But yeah, it is one such possibility. So you will see that, okay, the 6 possibilities are actually outside and the remaining 2 are inside. Cool. That is how we know, okay, the contribution of the outside one is actually a 0, but the contribution of inside one will actually be something. Now, it has done just one move. So right now I cannot find my answer by just saying, okay, the answer is 1 by 8 plus 1 by 8, because it is the probability, and we want to find the probability if it stays inside. And for sure, the 2 options to stay inside after one move are actually 1 by 8 plus 1 by 8, which is a 2 by 8. So I can just easily would have said a 1 by 4, which is 0.25. But it is saying move 2. So basically, I have to just keep on going until all moves are done. So basically, one move is done, I have to again do another move. Now you will see that, okay, right now it is here, right now it is here. Again, I will have to start. Right now it is here, right now it is here. Again, he has to go and start for all the 8 options. You will again see that the other 6 options are outside the grid and the remaining 2 are inside the grid. Okay. Also you remember, it is always doing a 1 by 8, because as soon as every time it just tries for one move, its probability get reduced by 8. So it was already 1 by 8. So it will become 1 by 64. 1 by 64. Again for this, 1 by 64. 1 by 64. And for sure, I want to find the probability, total probability. Simply, either it can be this or this or this or this or this, right? So that's the reason I just added things down and it became a 4 by 64, which is actually a 0.0625, and that is actually the answer. Now you know one thing, you will start from a point, you will keep, because you have to go to next point. As you go to the next point, you know, if you go outside, you have to return a 0, so that it will not be counted. Return a 0. If you are inside, return a 1. If you are inside, return a 1. But also make sure that if you are inside, at every step, at every k, you keep on reducing by 8. Because at every k, I am keep on reducing by 8 itself, right? Cool. That is how we have got so far information from the question number 1, and that's way too much information. Now coming back to example number 2, simply saying, okay, I start from the row and column as 0, 0. I have to do no moves at all, and still it will remain inside. So basically, no steps taken, it will for sure remain inside. 100% probability of him staying inside. That's the reason answer is 1. So for sure we know, and that is also what we saw in here also, that okay, if it stays inside, I will simply have a 1 as the contribution for that particular number. But as the moves are done, as another move is being done, I will for sure do a division by 8. Here itself, I would have said that, okay, the probability is right now 1, but as the moves were done, its probability keep on dividing by 8 because it has 8 options to go to. And that we saw from here itself, that how it has 8 options to go to. And the probability of every movement is 1 by 8 because it is uniformly at random. Cool. Now coming back to actually what we inferred from the example 1 and example 2. Example 2 was just an addition. Example 1 was more than sufficient to actually help you out. Now inference from every example, that at every step k, we have 8 options. So basically we are reducing by 8. Cool. Now probability at every step for other new steps is basically how we find it by dividing by k. Same as the above one. And for sure, if it goes outside, then we have no options, we have no contribution for that. So even if it is outside, so simply return a 0 for that. If it is inside, then I can return a 1. But make sure when you return a 1, you will have to accumulate or kind of modify depending upon k, because if it is inside, okay, it is inside, but still its value is 1. But as the another step, one move is being done, okay, it is 1 by 8, 1 by 8. Another move is being done, it is 1 by 64, 1 by 64. So contribution of being inside is 1 by 64. And then, okay, it is inside, saying that I will just simply say, okay, it is 1. The contribution can have, okay, 1 by 64 again also for the ones outside, but their contribution is actually a 0. That is how simply we can infer that, okay, once for inside, we will count their contribution, and for outside, we will not count. So simply by saying, okay, if outside, return 0, if inside, return 1. And this thing will keep on going sideways, keep on dividing on every k. That we will make sure when we write the code. But yeah, there is something which we need to infer from the question itself, which means the first condition, it just says, okay, if it goes outside. Now how to know if it goes outside? Simply by saying your R and C coordinates. If it actually, as you know how to move in 8 directions, you know exactly how to move in 8 directions. These directions you will know. You will make simply a 2D array of these directions and simply will keep on adding your directions of I comma 1 or I comma 0 in your x and y, and by this you can simply keep on moving the 8 directions by simply using a for loop of moving. If you have done the graph questions of how to move in the grid, how to move in the 8 directionally matrix, how to move in the 4 directionally matrix, it's same as we move in there itself. If you don't know, I highly recommend you should have watched the bar graph series. That would be very helpful. Now coming back to, okay, we know that we will see the movement. It will outside the grid, we will simply return a 0. Inside the grid, which means moves left. Remember, if the moves left are actually 0, then we will return a 1, because we remembered if the moves left were actually a 0, then I actually return a 1. The move here initially is started. So ultimately you will remember, okay, it will keep on dividing, but I have to stop when the moves left are actually 0. So, okay, if the moves left are 0, then simply return a 1. And this condition should be written after this condition. Why? Because if the moves left are 0, but still if it is outside grid, so it should have been 0, right? So firstly, make sure that it is inside grid, which means if it is after this condition, then only it will just make sure that I'm inside the grid, and then moves left are 0. So simply return a 1. Now for sure we know that, okay, it will just keep on repeating, which means I started from here itself, then it went to here, then again for this it just went to here. Then it can have multiple options. At every point it will again have options, and so on and so forth. So simply it's a simple recursion problem. The work is being done again and again. Why should I like put my brain? I will simply ask the recursion to actually put his brain. So I just simply say, okay, I have moves, I have R, I have C. Simple. And I have the directions array, and when I say directions array, it's the same array which I made above, which means 1, 2, a 2, 1, a 2, -1, right? A 1, 2, a 2, 1, a 1, -2, and so on and so forth. It's the same direction array which you make in simple graph to actually go on to next coordinates. When I say next coordinate, I mean, okay, R plus directions of I will simply iterate by simply saying I comma 0, it's nothing but the contribution of x coordinate, and I comma 1, it's contribution of the y coordinate. I'll simply keep on adding in my R and C to simply get the new R and new C. That's how I can simply get my new R and new C by this directions array, right? You don't have to manually go and do plus this. Simply make an array, then simply keep iterating on this array from 0 to 8, and then simply get actually your new coordinates, new R and new C. Now coming back to, as I did one move, for sure for my moves will actually get reduced by 1, but you also remember at every move I was keep on dividing by 8, so I simply divided by 8. It is 8.0 if you don't know it. I simply divided by 8. Now I have done one move, I have simply divided by 8, but you also remembered I was adding in my probability, so I will initialize my probability with 0. Then I will keep on simply adding in this variable called as probability, so as to get the actual probability. And you will know it is actually a recursion, so it will go and again ask for the above problem. So it will again go and ask, hey bro, what is for the next move? It will again go and return that. So if it returns a 2 by 8 for this, let's say for this step right here, it again for this, sorry, let's quickly remove it, bro, please just get done. Fuck, yep. So as you saw, damn, this is very slow. Cool. As you saw here that it just again did a contribution 1 by 8. So 1 by 8 was already there. It was just again doing a 1 by 8 here and 1 by 8 here, because we know at every new place I go on, I just did a 1 by 8. So basically it will just go and ask the answer for this. It will again go and say a 2 by 8 because it was for 1 for this particular and 1 for this. It will ultimately do a 2 by 8 upon 8. That's, you know, that at every move this 8 will keep on, it will be there, so it will keep on dividing at every move. It will keep on dividing. That's how you know that, okay, at every move this will actually make sure that, okay, your 8 is gonna increase again and again, 8 into 8, 8 into 8, as like that. Now you are simply adding in the probability, and that's how you can just get the sum of the probabilities, because it's nothing but, okay, either it can be this or this or this or this or this, the final locations of the actual R night. Now that's a rough picture which we drew off from actually the example 1 which we got. Now coming back to the recursion which we have made, for sure we can make the recursion, but as we are making the recursion, we know that, okay, it can be pretty big, it can go pretty big. So just looking backwards, is there any repeating subproblem can we see? For sure, in the example itself, we saw that if the knight at the stage, at the move 1, it landed here and here. Now at the move 2, it will again try to go at other moves, other places. So it just was able to go here and go here, go here and go here. Let's say if I had asked you, it also has a move 3. So it will again start from here and here, and then again try to go here and here. You now know one thing, right? You also know one thing, that when I started off with 0, 0 itself, right? And it again went back to 0, 0 itself. Now if I had again asked you, and you know for sure it is again the same stuff. It is again the same stuff, which means at step k equal to, it is again at 0, 0. So I would have, if I just asked you, if I had steps, let's say 3, so it would have again went on from this point and went here and here, and then again from here and here. So it is the repeating problem which these both will do for step 2, because they are the same location. So if they are at the step 2 and they both have to repeat the same process, then why not memorize it? I know it's a recursion. I simply saw it's a recursion, but simply I can memorize it. So what I will simply do is, I know that I have, and see, to represent the above thing I showed in picture, although you should have inferred from the picture itself that it is again going to the same place again and again. But if not, then you start from the 0, 0 at k equal to 2. You have 8 options. But I drew only the ones which I can actually show you, the above one. So it just went on to this to 2, 1 and 1, 2 at k equal to 1, which means one move done. Now for the next move, it again has k options, again has 8 options. So at every time 8 options will open up. For this, a 0, 0, a 0, 2, a 0, 0, a 2, 0. You will see here it is the repeating subproblem at k equal to 2, and that's, you can have in like many repeating subproblems, not infinite, many repeating subproblems in this. So for sure you know that, okay, you have recursion, you know it's a repeating subproblem. Simply apply a memorize thing. How simply, you know, R and C will for sure change, and at every step you know that your recursion involved k also, the number of moves. So For sure, that also needs to come in picture. So you have to memorize your R, C, K. Simply make a 3D array or simply make a string of this particular R, C, K, which means R plus C plus K as a string. And when you make a string, please use a delimiter, which means either a space or a hyphen or anything like that between three constants, 3 R, C, and K. And then you can simply use that as a string and then memorize it by simply using a map or anything like that. Or you can also use an array itself, a 3D array itself for memorization. Now you have got entire the logic. I'll say highly recommend quickly pause it and just go and code it out. But if not, then simply let's see the code. For sure, we know that we have to also memorize it, and we know that okay, we can either use a 3D array or we can also use a simple R string. We can simply make a string out of this R, C, K, which is R plus some string, which is hyphen or space, or I put my name as a string, or plus C, which is Aryan plus C plus Mittal plus K. That is how a string key will be made, and for that key I will simply have a value which is being memorized again and again. So I'll simply have a memorization of a string to double because I know that my probability is a double. And for sure, as you saw above, that I have a directions array which I have made. I know how I made. You also know how we made it. I showed you above. And then it is the main function, which is night probability. I just simply go and ask my recursion, hey bro, can you please find out what is the probability starting with K moves and starting with R, C. It just goes and just do the same stuff as you saw above. We have two base cases. If it goes outside bounds of my entire matrix, which means R less than 0, R more than equal to n, a C less than 0 or a C more than equal to n, simply return a 0. And if it is inside and the moves have reached 0, then simply return a 1. C, if it is inside, if it has reached here, which means it is inside and the moves are 0, then simply return a 1. Cool, my base cases are done. Now simply the part which comes is the memorization part. Simply I will memorize it as I showed you. I will just convert my R to a string, add a delimiter, a C to a string, add a delimiter, and then my moves to a string, and then my string key is made. And I simply go and find if that key is already there. If there, simply return that key. If not, then simply go on in the recursion part. In the recursion part, I initialize my probability as 0. Simply go on to all the directions, and simply go on and find, okay, moves -1, the new R coordinate, the new C coordinate, and also make sure to entirely divide by 8, because at every move I know that I have a division by 8. Now I will simply add this down, because for sure either it can be this or this or this or this or this, right? Simply add this down and simply I will get the probability. Now simply memorize it, which means simply put that in your map and simply return that particular part. And by that you can simply do the actual recursion plus memorization plus probability plus maths. Everything is being involved. That's a very, very, very good question. So simply the complexity is n into n for R into C into K for number of moves, and the 8 for all the directions which we go on. Space is also n into K, but it's actually a string which is being made, so that is a one kind of space factor. It's a constant factor which will come in picture. So that is how you can simply solve the problem. The code is down below. I hope that you guys got it. See, questions of probability, it can be very hard depending upon how bad is your probability or how badly you hate probability, right? I was one of the persons who hate, like I used to usually get confused on the things of probability and stuff, but thinking from the example itself and seeing how they build the example is actually very helpful. So I did not start from scratch and just say, okay, that is how you can simply think of as probability and made my own example. I just used the example of the question itself and then build it out. There can be chances that, okay, the example is not that perfect in the question, but there's a high chances that in Codeforces, CodeChef, and Leetcode as well, the example will actually be very good to actually start you and give you all possible hints for that particular problem. So I hope that you guys liked it. See you guys in the next video. Goodbye. Take care. Bye-bye.